So here's the deal. We're going to talk about the exterior angle theorem. And to do so, I'm going to use this little triangle here to demonstrate where does it come from? How does it work? Why does it work? It's not terribly complicated, but I am going to use a couple of letters at the beginning before we do some sort of an example. So let's take a look. Now, what the exterior angle theorem says, I will tell you in a second, but I first want to get to why it says what it says so that we feel confident with it, and then it'll make more intuitive sense by the time we relate it anyway. So here's my exterior angle, let's say. I don't know what it is, so let me just call it big C. Okay? Now, big C is going to be hard for me to tell from small c. So for the interior angles, rather than using big C and small c at all, let me just use Greek letters. As scary as those guys are, there's really not much to them. So for C, the Greek letter would be gamma. So I'll just put gamma. Looks like a little weird R there. And I'll call this one, just for the heck of it, alpha, and this one beta. Now here's what's going to happen. I'm going to think about the relationship between only, in the end, only alpha, beta, and big C, the exterior angle. And then we'll see why this theorem might come in use for you as you're doing things in geometry. So what can I say about this? Well, I know a couple of things right off the bat. The measure of angles I'm going to say alpha, and then beta, and then gamma, that's all going to be equal to what? Well, hopefully we feel comfortable with the idea of it being equal to 180 degrees. Could have said pi, but let's keep it in degrees today. So alpha, beta, and gamma all together is going to make 180. That's cool. That's fine. What else can I say? What about this relationship? This is something else that equals 180 degrees, doesn't it? So maybe I can get something out of that. In other words, I could also say that gamma, huge gamma, whatever. Now they're starting to look like R's because I said R. It doesn't matter. Gamma plus C, which is really an exterior angle, is equal also to 180, right? That should make sense. An exterior angle, by definition, is just a continuation of this line, basically. So that should be a straight line, and therefore any two angles that are only divided by a line in this way, another line, or another side, I should say, of the triangle, are together going to make 180 degrees. No big surprise there, right? So think about this. What does this mean? If we throw everything onto one or the other side, what's going to happen? In other words, I'm going to, since gamma is what I want to get rid of, right? I told you that what we're going to do is figure out what the relationship is between alpha and beta, and then big C. If that's what let's get rid of this guy. Let's get rid of gamma. Let's get rid of gamma first, and we'll see what happens. So I'm going to find out what gamma is equal to for each of these, and then we'll go from there. So let's see. If I move things around, actually, let me do it this way. I'm going to just put this guy right next to this guy. All right, so we're going to work with two different equations here. On this end, well, I can subtract, right? I can subtract alpha plus beta from both sides, and I would get this. I'd get gamma is equal to 180 minus alpha plus beta. And I got to make sure to put parentheses around that because I'm subtracting the whole thing. So technically it'd be minus alpha minus beta, but who cares? Subtracting that. Okay. Let's leave that alone. Let's look at the other side. This one's easy. Gamma is equal to 180 minus big C. Well, I've got two things up that are equal to each other, if only by nature of the fact that they're both equal to gamma. Let me do that. Let me take both of these sides and just set them equal to one another. 180 minus alpha plus beta. I didn't write my beta correctly. I hope nobody caught that. Doesn't matter. Maybe 180 degrees minus C. These are equal to each other, right? We see why. They're both equal to gamma, and gamma is going to be equal to gamma. So these are equal to each other. Now, what's significant about that? Let's see if I can simplify this a little bit. I've got 180 on both sides. If I subtracted from both sides 180, then we'd get this number. I'd have negative alpha plus beta equals negative C. But why the negatives? I don't need negatives. In fact, since I have a negative on both sides, why don't I just multiply both sides by -1 or divide by -1 or whatever have you? But if it's negative in that case, I could say alpha plus beta. I did it again. My betas are off today. Equals big C. And this is it. Whoops. This is what I'm talking about. This is the guy we want. This is the exterior angle theorem, as it's often introduced in high school geometry. And there's nothing more to it than this simple device, exterior angle theorem. We're simply saying that all things being as they are, that alpha plus beta, that is the two opposite angles to the exterior angle, are equal to the exterior angle. And you might have it flipped around in your book. It might say that big C, or the exterior angle, is equal to the sum of the two opposite interior angles. And that means the same thing, right? It means exactly the same thing. That's really useful. If only because if you didn't know that, you would have to first figure out what gamma is by subtracting what you know about the other two angles from 180, and then subtract again from 180 to get 1C. It just goes straight for the goal. If you know what alpha and beta are, you know what the exterior angle is. So as a very, very quick example, assuming that if you didn't get it in your head at this point, that you could always just leave, I'm going to just do a very quick example. Let me just make a quick triangle here. Okay, it looks like an equilateral, doesn't it? Actually, I forgot to make it one of them exterior. Let's see, I think I can just extend this way. There we go. All right, let's say I've got a triangle like this. And I know, for example, that this is, I'm going to make some stuff up. This is 70. And let's say I know that this is, it doesn't even look like 70 to me, but just go for it. And I'm going to say this is 60. I'm going to say this is 60. Now you do some quick mental math, and of course you can verify this. But what we are claiming here is that this exterior angle then must be equal to 70 plus 60, or 130 degrees. If you're not convinced, you should be, but if you're not convinced, what would this have to be? Well, this would have to be 50 for sure, right? Because 70 plus 60 is going to be 130. We just said that. And 180 minus 30 has got to be 50. But then if that's 50, then this has to be 180 minus 50, which is, again, just 70 plus 60, or 130. So hopefully you can see how intuitive this is. And if it didn't feel intuitive before, hopefully having seen the proof here, it feels pretty intuitive now.